So boys, now we're going to do some questions on gravitational energy. A 20 kilogram rock is resting on a cliff 30 meters above the ground. Find the gravitational potential energy of the rock. G equals 9.8. First step is to remember the triangle. Gravitational potential energy is equal to mass times acceleration due to gravity times the height. The units of GPE are joules, because it's an energy. Mass is always kilograms. Height is always meters. And G is about 10 on Earth. Now, in the question, they give us some numbers. 20 kilograms, 30 meters, and G. So, we must identify what these are. Kilograms, the SI unit, tell us a clue. Kilograms indicates it's a mass. So, 20 kilograms is a mass. Meters, as an SI unit, means height or distance. So, height, you could even use distance if you like. Distance or height, 30 meters. And G is 9.8. Although we said it's about 10, it's not exactly 10. 10 we use because it's easier without a calculator. But in the question they said it's 9.8. So if you said 9.8 or you use 10, they would give you about the same answer. So it's your choice. If you have a calculator, use this one. No calculator, use this one. Finally, they ask, what is the gravitational potential energy? So we go to our triangle, we cover up GPE, and we write down equals M times G times H. GPE equals M times G times H. Now we just put in the numbers. Mass 20 times G, I haven't got a calculator so I'm going to use 10, times height 30. 2 times 1 is 2, times 3 is 6. 0 times, we've got 3 lots of zeros here. So the answer will be 6,000, and don't forget the units of GPE, joules. The units of GPE are joules. And there's your answer. Let's say they ask you about the mass. What is the mass if it's 50 meters above the ground and it's got a GPE of 245 joules? So very simply again, we will write down these numbers. 50 meters tells you it's a distance or a height. 245 joules tells you it's an energy. And in this case, gravitational potential energy, because we have a mass and a height. And what's the formula for mass? We look at our triangle, we cover up M. M equals GPE divided by G times H. M equals GPE divided by M divided by G times H. Mass equals GPE divided by G times H. So that's our formula. We put in the numbers. GPE is 245 divided by G. We said if we don't have a calculator we can use G as 10. If you have a calculator you can use it as 9.8. And height 50 meters. So now we have 245 divided by 10 times 50 is about 500. If you look at the numbers, because we don't have a calculator, I'm going to do, this means roughly equal to. 245 is nearly 250 divided by 500. That's the same as saying 25 divided by 50, which is about a half. Mass equals 0.5, which is a half. and the units kilograms. Don't forget to put your units. For mass, it's kilograms. Just one last note. Gravitational potential energy is the energy to do with gravity, and if you have a ball, let's say at the bottom of a mountain and one at the top, or a hill, the gravitational energy will be greater here than here, because the height is bigger. Remember, GPE equals mass times G times H. So let's say the mass of the ball is 1 kilogram, and G we know is 10, about 10 on Earth, and the height here is 0, but the height here is 100. So if we find GPE for here, it would be 1 for the mass, 1 kilogram, times G, which is 10, times the height, which is 0. Anything times 0 makes 0. So your answer here is 0 joules. Whereas if you find the GPE here, we got 1 kilogram for the mass, times 10 for G, times the height, which is 100. Now you have 1000 joules. So you can see, the bigger the height, the more the gravitational energy. The smaller the height, the less energy for gravitational potential.